Hey everyone, welcome to Lhopitals Rule. This is Nicholas JMV. So we're finally going to get to Lhopitals Rule, which involves finding limits of certain expressions that are in indeterminate form. Indeterminate form can either be 0 over 0 or infinity over infinity. There's some other things that we're going to look at, but we're primarily looking at these two and primarily this one here when we see 0 over 0. So L'Hopital's rule involves taking the derivative of both the numerator and the denominator. Okay, so if we have the limit, let's say, of x is approaching maybe 0 of f of x over g of x, and we've got some conditions that we have to meet, but basically the idea here is you're going to take the derivative of the numerator and denominator separately until we can get a limit that's in determinate, not meaning it's not 0 over 0 over infinity over infinity. All right, so let's look at an example. So let's find the limit as sine of x over x. Now, normally you would say, okay, let's go ahead and plug in. That's our first rule when we take a limit. You substitute, right? So you take sine of 0 over 0, okay? The sine of 0 is 0, so here's in an indeterminate form. So what you can do now is just take the derivative of the top and the bottom separately. So the derivative of sine of x is cosine of x, and the derivative of x is 1. So now you can plug in 0. Once we simplify, the cosine of 0 is 1, and there is your limit. So that's using L'Hopital's rule. Very simple, but you have to have an indeterminate form. Okay, let's look at a couple more examples. Let's find the limit as x approaches 2x minus sine of x over x. So what I can do here is, again, if I plug in 0, and I'll go ahead and write this and try to find the limit, and I get something that's indeterminate. Okay, 2 times 0 is 0, sine of 0 is 0, this is 0 over 0. Now I can try using L'Hopital's rule, okay, because it's indeterminate. So I go ahead and take the derivative of the numerator. Derivative of 2x is 2. The derivative of sine of x is cosine of x, and that's all over 1, the derivative of x. Now I plug in 0 into my cosine. Okay, we know that cosine of 0 is 1, so this becomes 1 over 1, which is just 1. Okay, now it just so happens this second example is also 1. Okay, it doesn't mean every time it's going to be 1, the limit. Okay, here's our third example, find the limit. Now this is our first one where we're approaching infinity. Now, if I look at this problem, I'm approaching infinity. You can't take 5 times infinity, okay? But if I put a really large number over a really large number, it's going to infinity over infinity, okay? So this limit right now is infinity over infinity. I'm talking about putting a very large number over, excuse me, over a very large number, okay? So right now we're at infinity over infinity as x approaches infinity. So we go ahead and take the derivative of each separately, and I get 5 over 3, right? The derivative of a linear equation is a constant, and there's my limit using L'Hopital's rule. Last example, find the limit as x times cotangent of x as we approach 0 from the right. Okay, so when I write this, we're actually going to not have, we have an indeterminate form. I think it's 0 times infinity when we do this, right? When we approach it from the right, because we can't know. But I can rewrite this. Okay, so I'm going to go ahead and start by rewriting this. And I'm going to say x times 1 over tangent of x. Okay? Which now becomes the limit as x approaches 0 from the right of x over tan x. Now, if I put 0, if we're going 0 from the right, we're getting really close to 0. It's 0 over 0. And what I'll do now is just take the derivative. So I have 1 over secant squared of x. And so when I plug a number very close to 0, this actually also becomes 1. So that's using L'Hopital's rule to find limits of expressions. If you have any questions or comments, you can go ahead and type them below. We'll see you next time.